Hello friends. Welcome to NexMEP, your guide to MEP engineering excellence. In this channel, we cover everything about mechanical, electrical, and plumbing engineering. Today's topic is, How to Read Electrical Drawings Part 1, a complete beginner-friendly guide for site engineers, students, and MEP professionals. Before we begin, let's quickly look at what we're going to cover today. What is an electrical drawing? Symbols used in electrical drawings. What is a DB? What is a circuit? Types of circuit summary. By the end of this video, you'll be able to read and understand any basic electrical drawing on site. Friends, an electrical drawing is a technical diagram that shows the complete electrical system of a building or project. Think of it this way, just like an architectural drawing shows walls, rooms, and doors, an electrical drawing is the map of the electrical system. It shows where electrical equipment is located, how wiring is connected, how power is distributed, lighting layouts, control systems, and cable routing. Without this drawing, no engineer, electrician, or site team can carry out electrical installation work properly. Remember, electrical drawings tell you what to install, where to install it, and how to connect it. Now let's look at the symbols used in electrical drawings. Friends, in a drawing you cannot sketch every equipment in detail, so we use standard symbols to represent each item. For example, a ceiling-mounted light fixture has its own unique symbol. A wall light point has a different symbol. Switches, sockets, fans, DBS, TV outlets, data outlets, every item has its own recognized symbol. Some key symbols you must know: ceiling-mounted light fixture, wall-mounted light point, two-way switch, single-pole switch, 16A switch for geyser and AC fan regulator with switch, telephone, TV, and data outlets, bell push and calling bell, various socket outlets, 6A, 16A, 16A distribution board. Once you memorize these symbols, reading any electrical drawing becomes much easier. In electrical drawings, equipment names are never written in full. Instead, short forms called abbreviations are used to save space and time. Here are the most common ones you'll see on site. Abbreviation meaning AQ AquaGuard, AC air conditioner, CH chimney, FR fridge, MO microwave oven, DR dryer, WM washing machine, DW dishwasher, DG diesel generator, AFF above finished floor. Friends, if you don't know these abbreviations, you will struggle to read drawings on site. Make sure you memorize these. Now let's understand what a DB is. DB stands for distribution board. It is an electrical panel that receives power from the main supply, distributes electricity to different circuits, protects those circuits using breakers. Simple definition: a DB is the central command point that safely distributes electrical power to lights, sockets, ACs, and all other loads in a building. There are two types of DBS used in residential buildings: TPN DB triple pole and neutral used in three-phase systems, SPN DB single pole and neutral used in single-phase systems. Friends, that white box on the wall of your home or apartment, that is your DB. Let's now understand the difference between TPN DB and SPN DB. TPN DB, triple pole and neutral, receives three-phase power supply used in commercial buildings, apartments, factories, and large homes, can handle higher electrical loads, has three phases plus neutral. SPN DB, single pole and neutral, receives single-phase power supply used in small houses, shops, small offices, and apartments, handles lower electrical loads, has one phase plus neutral. Key difference are mentioned in the table. Now let's look inside a DB, what components are present and what each one does. Component function: main MCB, incoming protection for the entire DB, RCCB, earth leakage and shock protection, MCBS, individual circuit protection, neutral link connects all neutral wires, earth link provides earthing connection. When you look at a DB schematic drawing, you can see exactly how circuits are organized. For example, in a 3 BHK apartment you'll see separate circuits for lighting, power, AC, kitchen appliances, and utility loads. This is very important knowledge for reading and understanding electrical drawings on site. Now let's understand what an electrical circuit is. An electrical circuit is a complete closed path through which electric current flows, from the power source to the electrical device and back to the source. Simple definition: a circuit is a closed loop that allows electricity to flow and operate electrical equipment. The flow path is power source, switch, load, bulb or fan, return path, neutral, back to source. Main components of every circuit. Component function: source supplies electricity, conductor carries the current, switch controls the current flow, load uses the electrical power, protection device prevents overload and short circuit. Remember, if the circuit is open or broken at any point, electricity will not flow and the equipment will not work. In residential buildings, there are mainly two types of circuits. 1. Lighting circuit, used for ceiling lights, decorative lighting, bulkhead lights, mirror lights. Features: protected by 6A or 10A MCB, uses smaller cable sizes designed for low loads. 2. Power circuit, used for socket outlets, AC, geyser, kitchen appliances like induction, dishwasher, dryer, washing machine, microwave. Features, usually 16A or 20A circuits, uses larger cable sizes, handles higher loads than lighting circuits. Friends, this is why in every home, lights and fans are on a separate circuit, and AC and heavy appliances are on a separate circuit. It's all about load management and safety. Excellent! Let's quickly recap everything we learned today. Electrical drawings are technical maps showing wiring, lighting, power distribution, and equipment connections. Every item in a drawing has a specific symbol. Learn them. Common abbreviations like AC, FR, WM, DG, AFF are used throughout drawings. DB is the central point that distributes power safely using breakers. SPN DB single-phase systems, TPN DB three-phase systems. A circuit is a complete closed path for current to flow. Two main circuit types: lighting circuit 6A, a 10A MCB, power circuit 16A, 20A MCB. Protection devices: MCCB, overload and short circuit protection for high loads; RCCB, earth leakage and shock protection; RCBO, combined overload, short circuit, and leakage protection. Understanding all of this is essential for reading MEP electrical drawings effectively on site. Friends, I hope today's video was helpful and gave you a clear understanding of how to read electrical drawings. Thumbs up sign if you found this valuable. Please like the video, speech balloon, share your thoughts and questions in the comments below, bell, subscribe to NexMEP and hit the bell icon for weekly updates. Outbox tray, share this with your friends, colleagues, and fellow engineers. Every week we bring you new videos on MEP concepts, site practicals, drawings, and design tips, completely free. Keep learning, keep building. See you in the next video. Part 2 of how to read electrical drawings. Person with praying hands.